In the past, you may have used factoring using trial and error or the AC method, or maybe even some other method. But in this video, we're going to use a formula to find the values for x in a quadratic equation. So if we have an equation of the form ax squared plus bx plus c equals 0, we can use the formula x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, a, b, and c just represent the coefficients in front of each term. Let's use the formula to solve example 1 for x. Since we know that a, b, and c represent the coefficients, and my exponents are in descending order, I know that a is equal to 6, b is equal to 7, and c is equal to negative 3. Because of this, I can just plug it directly into the formula wherever there's a letter in the original formula. I can substitute it with a number. Negative 7 plus or minus the square root of b squared, 7 squared, minus 4 times a, which is 6, and c, which is negative 3, all over 2 times 6. Now I need to simplify this. X is equal to negative 7 plus or minus, let's do the inside of the radical first. 7 times 7 is 49. 4 times 6 is 24 times negative 3. 2 times 6 is 12 in the denominator. Further simplifying, we're going to have 49. 24 times 3 is 72, and a negative right here times a negative right here is going to be positive. It's okay to show all these steps. In fact, if you're struggling with this, I highly recommend that you do show all the steps so you don't confuse yourself later, especially if you're going back to this section to refer to it and try and figure out what you were doing if you forget. So 49 plus 72 is 121 all over 12, and 121, if we take the square root of that value, it's actually 11 times 11. So let's rewrite this as 11 squared. And if we take the square root of 11 squared, we're just going to have 11. So I'll write that in the next step. So I will get two solutions for this because of the plus and minus sign right there. So remember, if you have a plus or minus sign in between your numbers, you're going to need two solutions. So negative 7 plus 11 all over 12. And the other solution will be negative 7 minus 11 all over 12. So this will give me x equal to 1/3 or x equal to negative 3/2. In example 2, we have negative 5x squared minus x plus 2. So a is equal to negative 5, b is equal to negative 1, and c is equal to 2. Using the formula, again, x is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. We just simplify by substituting in those values. Since b is negative, and we have a negative b here, it's minus a negative 1 plus or minus the square root of negative 1 squared minus 4 times a, which is negative 5, and c, which is 2. All over 2a. So x is equal to a negative times a negative. Right here is a positive. So 1 plus or minus the square root. 1 squared is just 1. A negative times a negative is a positive. 4 times 5 is 20. 20 times 2 is 40. And 2 times negative 5 is negative 10. From here, we can simplify the radical just a little bit more. 1 plus or minus the square root of 41 all over negative 10. In this case, since 41 is not a perfect square, we cannot take it out of the radical. However, the denominator is negative, and we tend to not leave negatives in the denominator. So, we're going to rewrite it and put our negatives in the numerator instead. This is in effect doing the same thing as dividing. Take that back, multiplying by negative 1 in both the numerator and denominator. So since this is equivalent to a 1, we're not changing anything, we're just changing the format, the way it looks. A negative times a negative, once again here, is a positive, and I have 10 in the denominator. This does not look like it should be done, but it is, because we cannot simplify this radical further unless we do a calculator computation. So this is your final answer.